We are quickly jumping on to our next panel discussion that we are going to start in 2-3 minutes so that we can set up the stage for the wonderful discussion that we're going to have. The topic of the panel discussion is India storage market ready for takeoff. The session is powered by Bridge to India Private Limited. May I please request all the respected dignitaries, our speakers for the session, Ms. Sanskriti Dubey, Senior Manager, Market Growth and Communications, Fluence India, to please be on the dais. Mr. Praneeth Pillariseti, Senior Product Manager, Stationary Storage Systems, Log9 Materials. The next speaker for the session we have Mr. Charan Kuppili, Technical Director, Jinko Solar. Requesting Mr. Naveen Nagpal, Assistant Vice President, Renewables, BESS and New Initiatives, BSES, to please be on the dais. Also requesting Mr. Ved Prakash Tiwari, Assistant General Manager, O2 Power, to please be on the dais. Last but not the least, requesting our respected moderator, Ms. Neha Makol, Manager Consulting, Bridge to India. Over to you, Ms. Makol.
Thank you. Thank you so much. Just quickly introducing myself, I'm Neha. We are from Bridge to India. For those who don't know, we are a renewable energy focused company. We are wholly and solely focused on the clean energy sector. And very thankful to Informa Markets for inviting us here to moderate the session and to deliberate on this very pertinent topic, the battery storage market. So I'll just set the context for today's discussion before we move on to the panel discussion. There is a growing renewable power in the grid, and that has highlighted the need for battery storage solutions. There is a very favorable market landscape today that did not exist few years ago in terms of prices, in terms of policy and regulatory framework, and even so, the supply chain is also getting more sorted out. Even we see that the renewable penetration stands at only 10 to 12%. We see a trend that DISCOMs are moving away from vanilla renewable projects to more RTC power solutions or firm and dispatchable power solutions. Within the energy storage solution space, battery storage solutions are more preferred because of a lot of advantages that it offers. So we're going to cover topics including techno-economic feasibility, price and growth outlook, what are the market use cases and applications, and what is the technology landscape. Before we move on to the discussion, I would request all of you to please introduce yourself and your company to the audience.
Hi, I'm Sanskriti Dubey. I'm Senior Manager Market Growth from Fluence. Fluence is a global leader in battery energy storage systems.
Hi, I'm Praneeth. I'm with Log9 Materials. I'm a Senior Product Manager for the stationary storage segment. Log9 Materials is a young company. We've been one of the fastest growing companies in the EV space, recently venturing into stationary storage as well. That's about us.
Good evening, everyone. I'm Charan Kuppili from Jinko Solar. I'm the Technical Director for South Asia and Central Asia market, wherein which we try to deal with solar PV modules as a manufacturer and even in the energy storage segment as a kind of complete solution provider. Probably we'll discuss more in detail going forward. Thank you.
Yeah, good evening, everyone. My name is Naveen Nagpal, and I work for a power distribution utility in Delhi, that is BSES Rajdhani Power Limited. Thank you.
Yeah, my name is Ved Prakash Tiwari. I am working with O2 Power. I am looking after the storage at O2 Power.
Thank you so much. Thank you so much for taking out time and joining us today. We have a brief presentation by Sanskriti, and she'll set the context for today's discussion, and then we'll move on to the panel discussion.
So for today's session, I'm covering a brief details of what is India market landscape for battery energy storage system. Let me introduce Fluence. Fluence is a global leader in battery energy storage solutions, and it also provides digital offerings to the Indian market and to the global market as well. So Fluence so far has deployed 6.2 gigawatt of battery energy storage solution in 40 plus countries. So today, with the topic we have is India energy storage market ready to take off. Now today, this is my third consecutive week wherein I'm presenting and talking about battery energy storage project. And if you had heard me before, I'm sorry, I empathize with you. But if you're new, I'll make sure to enlighten you. So this statement I made because we are not ready to take off. We are already taking off. We have already taken off. So with this, Fluence started its journey in 2019, deployed India's first grid-scale battery energy storage project, which is a 10 megawatt asset deployed in Tata Power Delhi distribution area, which is in Rohini area. And this serves a lot of applications like peak power management, DSM regulations, frequency regulations as well. And since then, Fluence now is presently deploying its 75 megawatt, 150 megawatt hour, one of first larger scale grid connected battery energy storage deployed along with solar, wind and battery energy storage solutions. Fluence has also formed a joint venture with Renew, which is an independent entity serving market exclusively and providing localization benefits to the Indian markets. So when we talk about this project, this is a 75 megawatt, 150 megawatt hours, 2 hours peak power management. And this was under a tender which was invited by Solar Energy Corporation of India in 2019. The power purchase agreement were signed with two distribution utilities. One is Goa and the other one is Haryana, which is taking 150 megawatt each from the project. Now if you see the configuration, this is 2 hours in the morning and 4 hours in the evening. The contracted capacity is designed in such a way that this will provide a peak power to these two distribution utility for 2 hours in the morning and 4 hours in the evenings. Now the PPA with this distribution utilities is 25 years. And the battery will be for a 20 years lifetime for one cycle utilization. This includes the augmentation time as well. Now, I would like to make a point over here that when the project commissioning started, from the time it take for us to, sign our procurement contracts and everything and place our orders, it just took us 4 months to bring this solution from the port area and deployed it on the ground. This is how readily it is available and this is how modular the product is. So this, and at present when I'm talking, we are expecting this to be commissioned maybe within the next 30 days, and this will be the first larger scale project. Now, when we talk about the tariff, the prices which is applicable from this contracted capacity, so the tender which was designed has two ways, one of the off-peak tariff and the other one was the peak tariff. Right now, we have a blended tariff structure in the Indian market, which is called the hybrid tariff structure. So if you had to...
And that what the adoption is of battery storage solutions in the market as of today, and what are the emerging application and use cases?
So on the utility scale, I think Sanskriti has touched on it quite a bit. On the commercial scale, actually, it's quite a few customers are now interested in going scope 1 and scope 2 completely carbon neutral solutions. So there's a lot of use case there wherein they can purchase renewable energy, store it in the batteries. And the only thing is that the price parity, the customers still expect that we should still achieve price parity, including the battery cost as well. So that is a challenge I think we have to kind of rise up and meet. But otherwise, there are good use cases for commercial industrial, a lot of warehousing and commercial buildings as well. Where they want to completely go purely based on renewable energy. So I think those are great applications that are coming up.
Thank you. Sai.
Thanks, Neha. It was a nice presentation by Sanskriti, wherein which she has covered most of the topics, more specific to application part. And if you just try to understand the market on the case of these kind of applications, whether that can be with DG segment of or utility scale or C&I market, on all these applications, everyone's target is to reduce LCOS, levelized cost of storage. And this particular LCOS completely targets or depends on 7 major factors, which is like CPR on dias, which means one is the cost, performance, and then reliabilityness of that particular specific product, durability, where number of cycles or the number of years, whichever is going to be committed for that, and impact on the environment, more importantly, which is what is required on any kind of scale of these particular technologies getting into the market. And other factors also, which is completely linked to the availability of these raw materials. And lastly, the safety factors, which is what is required for current market scenario conditions. If we try to concentrate on all these particular aspects, relatively everything is interlinked, where in which it can address the specific need, requirement of any kind of application. And in that particular sense, which is what we are trying to do is that on all these particular 3 applications, we try to match these particular 7 metrics. And specific to utility scale, if you just try to see, it's all about increasing the energy density. How good we can increase this particular existing energy density, starting with this particular existing LFP kind of technology option with 3.2 volts as a kind of a base variant with 280 Ah or 300 Ah. This is a base variant which can be stacked in cells to module, module to rack, rack to pack, and then as a kind of simple container, you can do that, which is what is available in the market. But how can we optimize this more? It's again like going forward, we need to concentrate on these particular material availability, which is the reason why we could see the sudden decline in the price of this particular market, which has happened in the last 2 to 3 weeks kind of timeline. Going forward, what can we expect within the same technology optimization? People will try to maintain better energy density with increased ampere hour capacity of the same cell size. But yes, within how much time frame we can expect that? Probably within a span of 4 quarters to 6 quarters, we could see drastic change in these particular cell chemistries. And thankful to Government of India, wherein which even our government also has started through a national policy of ACC, which is more of advanced cell chemistries. Through that particular process also, we can try and see better efficiency products, which are going to concentrate more on the specific energy density. It's going to happen with lithium ferrous phosphate itself, or even going forward, we even can find the sources which are available in abundant, specific to sodium ion kind of applications as well. But yes, if we just try to see, everything will figure down to LCOS of these particular solutions, whether that can be with residential energy storage segment or C&I segment, or even for this particular utility scale kind of segment.
I think on the utility scale, I think one segment that might be upcoming is the DSM mechanism. I don't know if you had it on your PPT, but there are renewable plants are losing revenue because of DSM, and going forward as renewables become bigger and bigger part of generation, the DSM mechanism, the intervals of time, it's going to be more stringent, the penalties are going to be higher. So I think that's an emerging use case, and there are people who are exploring lithium ion for those applications. But I don't know if anyone's done like a good use case or not, but that is an emerging, I think, use case that's coming up.
So it's great that we have a DISCOM perspective also with us. So Naveen, I'll come to you. And I want to understand that what is your current renewable penetration? Are you struggling with accommodating more renewable power? And what are the specific and immediate use cases within the DISCOM's operation that can be effectively addressed through integrating battery storage solutions?
Yeah, thank you, Neha, for inviting me in this session. And as far as renewable penetration you asked for, so we are about to touch nearly 50% of our portfolio in terms of megawatt terms by end of this year. So it's going to be a huge, when we say how to manage that kind of variability and intermittency into our portfolio. So that could be one of the challenge. But before I come to that, let me just discuss about the key objectives for which a DISCOM works. Like there are 3 key objectives. One is the kind of providing power available to the consumers 24/7 with reliability and quality. The second key objective is the providing the affordable power. That means the power which we procure that should be affordable to the consumers. And third would be kind of accessibility. That means power has to be made available to each and every consumer, whether it is at the far end of my license area or it is at the load center. So we have to make power accessible to all consumers. So these are the 3 broad key objectives for which a DISCOM works for. And over to this, now we have another mandate of clean and green power into our portfolio. Like we all know, DISCOM is an obligated entity, and we have renewable purchase obligations, which mandates a certain amount of energy to be procured from renewable energy. Of course, we are meeting over and above our compliance, over and above our obligation, but the question is whether we can sustain that kind of variability and intermittency which these RE brings into our network without having any flexible or balancing source. So I think not for long term. In long term, we have to find a source which can provide flexibility, which can act as a balancing source into the network. This, of course, could be in terms of battery energy storage, or maybe in terms of, say, automated demand response, or maybe certain gas peaker plants. But of course, battery energy storage seems to be one of the most prominent candidate in this race, because the storage systems can help us in providing the kind of support in both the directions. Like batteries can act as generators at one point of time, they can act as load also at the other point of time. So batteries would definitely going to help us in managing our power portfolio. And there are many use cases other than managing the demand and supply mismatch. When I say batteries can help in meeting, providing the balancing power. So other than that, there are many other use cases, say ramping support. When solar is going down during evening hours, so batteries can easily provide the good ramping support at a very fast rate. Batteries can help us in avoiding the deviation settlement penalties which we face due to the kind of mismatch between our scheduled demand versus the actual demand which we face from the consumers. And over to this, we have many other variable supply sources in terms of distributed energy resources like rooftop solar. So we are also promoting rooftop solar. So like in our area, we have almost integrated 120 megawatt of rooftop solar. So that again, along with the demand side variation, now we have supply side variation also from the consumers, or we say prosumers. So all these challenges can be sorted with the support of battery to some extent. So I would say battery is going to be one of the key candidate in the power portfolio of our DISCOM in coming years.
And I think BSES has already executed some projects which are small scale projects. So can you also share with everyone what are those projects and what are the use cases?
Yes, of course. We did some small pilots of battery energy storage systems which are integrated with our distribution transformers. Those are, of course, kilowatt scale projects. These were commissioned nearly 1.5 years back. And the primary objective to put these battery energy storage systems was to defer the augmentation of our conventional assets for coming years, so that if my assets are going overloaded for certain duration in a given year, so that overloading can be mitigated by using these batteries during summer months, primarily June, July, August in Delhi. And during non-summer months, we can utilize these systems for energy arbitrage. That means when prices are low in the market, we used to charge these battery systems, and when prices are high in the market, we get support from these batteries and we avoid buying costlier power from the market. So these were the two primary use cases for which we did this pilot, and these sites are running fine for the last 1.5 years. And other than this, we are implementing 3 another projects under a different project which are under implementation. That is also at the DT scale level. And one site is kind of replacement of DG genset at a society. That pilot we are doing with one society. And other pilot we are doing with a educational university where time of day tariff can be utilized to provide them the benefit of battery. And in addition to this, we have recently put one RFP also for a grid scale project of 20 megawatt, 40 megawatt hour, which is bids were received yesterday, and this project will be opened up very soon. Thank you.
Thank you. Ved, I'll come to you now. So there are, like Sanskriti presented, there are several tender designs that have been getting tested in the market, including RTC, peak power, and now firm and dispatchable power tenders, and also standalone storage system tenders. and you have participated in a couple of them. Wanted to understand from you how attractive it is for a developer to participate in these tenders, and moving forward, where do you see the market going? Do you see more these kind of storage plus power blended solutions, or do you see standalone storage tenders also coming up?
So yes, we have participated in the standalone tenders which were there, the peak power, the RTC one, and we would be participating in FDRE tenders. So to say so, there is a requirement of each type of tenders. So you can't say that forthcoming all the tenders would be either peak power, RTC. It won't be, because I believe that probably there is a market which is specific to standalone storage, which needs to be catered. The regulation needs to come up for standalone storage, because standalone storage can be used for ancillary services, which is still the most untapped market in Indian context. With respect to storage, storage is primarily being used for energy shifting, whether it is peak power tender or RTC tender. So yes, when we participated in peak power and RTC tender, we tried to evaluate other technologies apart from solar also, because post-COVID, there was an increase in battery prices, the expectations which the tendering authority were there. No one will be able to match, no one would be able to match that expectations at that point of time. So we evaluated other technologies also. With respect to standalone tenders, I believe the regulation part, which is a bit weak, that is need to be focused. That if I am having a standalone energy storage, so one use case probably would be of peak shifting or energy shifting. With respect to ancillary services, I heard that few of the exchanges, they have also proposed with respect to this ancillary service, tertiary reserved ancillary services, that there should be a similar kind of GDAM or real-time management also, real-time scheduling also. They have proposed some tariffs also. I believe for DAM they have mentioned 12 rupees, and for real-time market they have proposed 50 rupees per unit. So that would serve as a different use case for BSES, and probably we would have more stable grid. With ISTs coming into picture, keeping storage at one location and keeping your wind, solar and other intermittent sources at other location, somehow probably won't stabilize the grid, because you need to have storage behind the meter to have that flexibility in your system to provide the grid stability, whether it's frequency regulation or voltage control from your system. On peak power tenders, the requirement is as such that probably batteries are making more sense, because the peak hours are divided into 2 segments, so there is enough time for that. And yes, the bids which have been concluded, most of them were with battery only. So being a developer with respect to the government tenders, this have been our approach. Recently, we have also seen that in C&I market, there is much request with respect to the, not specifically round the clock kind of power requirement, but a typical power requirement which is almost firm kind of, like a source which can provide 80% of firm power on an annual basis. That is something which is okay with in C&I segment. In C&I segment, the requirement which is there right now is mostly being met with only 2 sources, either solar or wind. Probably you need not to have a storage, because the storage is yet not that commercially viable. The solar and wind, the LCS, as Sai was saying, is the main point which is there for the clients also. So the decision making is on the basis of LCS only. So right now what we are proposing probably solar and wind, because battery prices are still on the bit higher side. But we need to oversize our system. We are oversizing our system, and we are basically taking a trip on the merchant market. Our merchant exposure is increasing as soon as we increase the solar and wind prices. So with the storage, that is something which we can basically reduce the LCS and match the requirement of clients.
Okay, thank you. Sanskriti, I'll come to you. So batteries, as we are talking about, the LCOS is the most important component, and India is a very price-sensitive market, and there is also a perception that international system integrators are more expensive. So how are you keeping it attractive for your consumers and making it making it commercially viable for them?
So I don't think so there's a challenge over here, because if you see the project which is already ready and being deployed on the ground has a LCOS cost of 4 rupees 30 paise along with solar and wind. That was in 2019, which was very much competitive with the pump storage, which got awarded with a 900 megawatt capacity. And if you see the latest tender, which came up by SECI, which was the hybrid tender, the tariff discovery, that also, I presume because the tender configuration was such that it has the configuration of solar, wind, and battery energy storage. Energy storage was the configuration over there. And mostly people who won the bid used the battery energy storage configuration. And that came up with a tariff of 4 rupees 64 paise. So we are very much competitive. We are over here. And I'm hoping that it was our proposal with which all these developers won the contract. So I'm sure we are competitive. We are here. And obviously, when you talk about how can we make it more competitive in the market, we are doing, what Fluence is doing is kind of experimenting with how we can supply localized product in the market. We can't do that right now. We are developing, we are seeing how the market structure is performing. But as the industry is progressing towards Indian industry, basically to provide more of localized product in the market, we are going in that route, and maybe 2 or 3 years down the line, we have a local product requirement over here. And with this, with 4 rupees 64 paise, we can expect more down kind of cost in the tariff discovery.
That is very positive to hear. Sai, will come to you. I wanted to ask you to throw some light on the technology landscape. Are LFP batteries going to be the way to go forward, or do you see more batteries like sodium-based batteries also to become a part of the mainstream battery storage solutions?
Okay. So more importantly, if we just try to look at the landscape of this existing technologies, anyway, liquid state technologies, they went into a kind of different mode of optimization, where in which they cannot meet the existing energy density values what exactly is being portrayed by solid state devices or solid state technologies, which is being offered through, after lithium ion, it has came up to LFP, lithium ferrous phosphate. And going forward, there will be some kind of optimization which is going to happen in this. And this space is going to be continued for the next 4 to 6 quarters. Even you can expect that particular 6 quarters even can be extended up to 10 quarters kind of timeline also. The reason why is this happening? Because there are certain safety test beds which has to be created, which are still pending. Not only in our market, elsewhere also this is not yet tested as what the kind of extended reliabilityness has to be tested, which is what has happened with solar PV as well. Way back 10 years back or 15 years back, if you just go to solar PV, it was a simple IEC 61215 standard. The same thing is now happening with this existing technology of 61000 only. Slowly and gradually, we will move towards 62619. Anyway, which is already there as a kind of global standard. And going forward, what can be expected? It's only the A standard of 62459. A is one of the standard which is there for secondary cells. Apart from that, what else are the major standards which is driving this particular technology to stay for longer tenure or as a kind of acceptable product across all different kinds of segment, which is not yet done. So a lot of test beds are getting developed. A lot of enhancement has to be made on these particular things. Once these particular things gets a kind of wider acceptance, not just limited only to this particular standalone tenders, even for all kinds of applications. When this particular technology optimization and technology enhancement and technology adoption is going to happen on all these particular sectors, then definitely we can say that this technology improvement is going to happen with next wider scale with other technology. As of now, lithium ferrous phosphate is in the phase of second stage, we can say. It's a kind of second stage of technology after lithium ion or lithium titanium kind of technology. Now going forward within this particular lithium ferrous phosphate, we can see hybrid passivation is going to happen. And this particular hybrid passivation is going to happen for the next 6 quarters for minimum, which is going to test it for all different kinds of climatic conditions as well. Because as of now, it's not yet tested. It's tested as per IEC 61000 kind of standard only. But the kind of extended reliability kind of test conditions, if we just try to see, as what has happened with solar PV, where we tried in coming with not just limiting ourselves only to salt mist condition or corrosion activity, or even for the many other factors of abrasive kind of conditions as well. All these particular conditions with increased temperature conditions also has to be tested, because LFP has got the only disadvantage is that with the increase in temperature, there is a lot of duration which is going to happen. Beyond 45 degrees C or 50 degrees C, you can see that particular duration happening. Everyone will try to be silent on that particular segment. But yes, that is going to be addressed in very short tenure of timeline. So when this is going to be addressed, you can see the ramp up of these particular energy density values going like anything. Once these particular energy densities will shoot up, you can expect that this can be competed with any kind of new, chemical vapor deposition kind of technologies also, which are going to come up in this particular LFPE or going forward with sodium ion kind of technologies as well. But yes, for the next 10 quarters, you can bet on LFPE with different optimizations as what has happened. Like instead of 280 Ah cell, it will come up with 300, 320, 350, and it is expected to touch up to 500 Ah down the line within span of 6 quarters to 8 quarters kind of timeline. That's what is expected.
And can you also share what is the price delta between the imported batteries versus the domestic?
Yeah, price is a kind of right question, but to a wrong person. The most important aspect is that you can see that like the kind of volatility what has happened in last 2 to 3 weeks itself. Last year, on the same dias, even Sanskriti was also there, where the price was standing at around like $280 to $320 per kilowatt hour. Now you can see where it has came down. And going forward, if you ask us where exactly it's going to step in. But yes, down the line, it is going to be stabilized. That's what is expected, but not sure of a kind of confined number or a kind of range. But yes, that's pretty much thing which is what is expected from the market also. And it completely depends on the availability of these particular raw materials. That's where, because at the end of the day, cost is a major metric. We have to reduce on the capex and also on the opex. Only then your LCOS can be addressed. For this particular thing, what exactly we are trying to do is that we are trying to reduce the auxiliary consumption within the segment, so that we easily can see that LCOS is coming down at least by 20%, so that our product is going to be pushed in the market with all kinds of, not only with economies, but also with all kinds of efficiencies and energy densities, which is what is required at the end of the day.
Praneeth, any thoughts on this technology landscape and market prices?
Yeah, so I have a slightly philosophical take on it. So I'm actually excited about the new sodium ion. I think it's going to create a level world across the world. So right now, China is the world leader in terms of lithium ion, right? So whether it's a few years down the line, 5 years down the line, when new technologies come, I think it's going to level the playing ground again. And it might be our opportunity to be the world leader, to have, in terms of lithium ion, be where China is today. We could be the next sodium ion battery powerhouse, right? So that's my take. I think I'm excited about the changes. And even in LFP, there are a lot of new technologies coming up. Our company, Log9 itself, is developing few exciting products coming up in the next few years. So I think as the technology evolves, it's going to kind of level the playing ground and help us like compete with China on equal terms. Yeah.
Also, as a domestic manufacturer of batteries, what are the kind of challenges that you are facing while you're developing the manufacturing base in India? And any support that you think that should be provided by the government to help you build these capacity?
I think a couple of things here. I think our raw material supply chain still needs to be stabilized. Right now, we have a policy of trying to multi-source. So we have like our R&D head likes to call it China plus one policy. So we have one supplier from China, and then we have like 3-4 other suppliers across the globe that we try to stabilize. And even though they're not as effective, not as cost efficient, not in terms of technical parameters, we try to work with them and build them up so that in the future they can be on par with the Chinese suppliers. So that takes a lot of effort and cost from our side. So I think that's one thing, that we are working hard on. Another thing, actually, VGF is a really good help for a lot of domestic companies. I think we were talking about LCOS and comparing it with the bid pricing. So right now, the LCOS, I think the VGF will actually help quite well to bridge that gap. What would make it even better is if we have, instead of just one size fits all kind of a VGF, if we can have like a slab of VGFs where based on the level of indigenization in the components, if you can have multiple levels of VGF, wherein Indian manufacturers and Indian raw material suppliers can get the maximum benefit versus some company who's just importing the packs from China can get a limited amount of benefit. I think that will really catalyze not just the battery manufacturers, but also the raw material manufacturers in India. Like similar to what happened in solar, right? We had the domestic solar cell manufacturers versus people who were importing solar cells. So they had different levels of subsidy. So something similar in the VGF would actually not just kickstart the installation capacity, but also kickstart the ecosystem of raw material manufacturing as well.
Yeah, but I think we all can agree that the quantum of VGF that has been issued is very small compared to what the kind of demand that we are expecting by 2030. It's only for 4 gigawatt hour, and if we look at the CA numbers, we are expecting more than 200 gigawatt hours. So do you think that this will provide the initial kick into the market?
Yeah, I think it starts off, it helps to build the capacity and probably bring down the domestic prices. Yeah, I can't speak to what what kind of funding we can expect in the future, but it's definitely a good start. I think it will help to kickstart the ecosystem. Yeah.
Understood.
Can I add? So on the VGF funding, I think this will definitely kickstart the market. The reason being, see, prices are already cheaper. Okay, it's not that from the LCOS side it is very higher, because if you see and compare it with the energy exchange prices, DISCOMs are already buying the costliest power of 10 rupees. And if you see the DSM market, the frequency regulation market, there were prices at instances which touched 30 rupees per kilowatt hours, and DISCOMs did buy that. So this VGF will be kind of support to DISCOMs to pursue this ESS plus RE tenders or standalone storage tenders, and secure the quantum which they are expecting in that range. So and I think the more we go ahead with 2030 target of 41 gigawatt kind of requirement, slowly this kind of support funding may be widened for all these developers as well, because what we hear and what we think is these supports are giving to now being given to developers to build these projects. So I think that will facilitate the market more.
Since we are on the subject of the policy and regulatory framework, Naveen, there are energy storage obligations also imposed on the DISCOMs, and we see that Delhi has issued a draft RPO target, but we see the ESOs are missing from that document. So are there any discussions or indications that if Delhi is going to adopt the ESOs, and just from a DISCOM perspective, how hard do you think it would be to comply with those targets?
So like you rightly mentioned, the MOP has given ESO requirements in their trajectory, but the same has not been replicated in DRC regulations, what we see. So they have specified only the renewable purchase obligation, not the ESO. But like I mentioned earlier, with the introduction of renewable energies in power portfolio mix of our DISCOM, the energy storage makes a natural use case which needs to be introduced in the power portfolio. Else, it would be very difficult for a utility to maintain their grid with the required stability and reliability. So, irrespective of defining ESO by the regulator, we look forward for putting more energy storage projects into our area. And I would say we also need to understand like energy storage is not a source of energy. It is a kind of a peaking reserve or peaking resource. It's a capacity resource. So we should not confuse between the energy versus capacity. Like in many of the cases I heard, like the levelized cost of energy from the storage is very high when we compare with the cost of energy from coal plants or wind or solar. So that is not a right kind of comparison. So we should look energy storage as a capacity resource, and we should treat it like that. So like SECI did its last tender in terms of per megawatt per month as a capacity, not as an energy. That is the right way of doing it. Another important thing is like even if we need to compare in terms of per unit, then it would be more prudent if we compare it with the kind of value of load load, kind of how we can avoid the load shedding from these battery systems. So if we can avoid that load shedding or we can compare then the value of energy from the battery with the value of lost load, or maybe the kind of energy which consumer has to buy from a DG genset. or maybe a gas peaker plant cost. So that is the kind of comparisons we should do, and then we should look whether really ESO is the mandate which DISCOMs require to go for storage.
Thanks, Naveen. We have established during the discussion now that the market is evolving, the market is volatile, the prices are changing, the technology landscape is also evolving. And in such a volatile market environment, what are the kind of operating assumptions that you take into account when you're bidding for different tenders? I want to understand that how you think that, okay, this is how the market would change in the few years and this is what my price should be.
So most of the tenders which have been awarded by SECI or SGVN or NTPC, the construct of all these tenders are such that we have to take assumption on each step. First, if it's a peak power tender, we'll have to take first assumption that what would be the peak hours, because the first assumption should be either worst or best. That's the way we have to approach. So with respect to the storage part, if I have to, so the main part is that what would be the capex reduction over the period of time. There are reports like BNF does this particular study. Those numbers which they show, they are too much optimistic. They believe that probably the battery prices would be half what it is right now, almost 50% decline in the next 7 years. So that conscious call needs to be taken from our end, that what should be the capex year-on-year capex reduction. Then what should be the strategy, whether to go for an upfront overloading in the batteries or to go for an augmentation kind of plan. Then the replacement part, that LFP batteries comes up with 20 years life. Our PPAs are of 25 years. So now the first call is to take whether to consider a replacement after 20 years or to design something else. So these are the assumptions which are there. Market itself is in very nascent stage. Two tenders can't be compared. Each and every tender are different from each other. So we have to do this analysis every time. And let's see that which kind of assumptions which we are taking really bear fruits or not.
Thanks. Thanks, Ved. I would not direct this question with to anyone, just anyone who would like to take this. In the recently issued energy storage framework, there was a mention of ALMM also for battery storage solutions. So just wanted to get your thoughts on this.
So I think if you compare the ALM with the solar industry, this was announced in 2019 for solar developers, and by 2019 it was already 10 years for the solar industry to kickstart this market, had the demand, had the configurations ready, the developers, the module manufacturers were ready for the Indian market to provide that kind of supply. If you compare this with the battery storage industries, we are still at a very, very initial stage with no visibility of demand over there. Like we know that by 2030, 41 gigawatt is there, but if you look at the present, we don't have enough revenue stream. So I doubt how a company will look forward to this market for creating such kind of investment, so that, you know, I think that with ALLM being introduced at this stage, will kind of create a barrier for the market entry. So we should wait for this, I think maybe 5 years down the line, when we have all the kind of level playing field available with the BCD and GST exemptions. We have tenders and the DISCOMs which expect these tenders to be ready with battery energy storage solutions. Once these are all streamlined and kick-started, I think then this ALM introduction will be beneficial for the industries. That's my view.
Any other thoughts?
Yeah, absolutely. I just would like to top up on Ved's remarks, because every energy storage system is highly customizable. Everything is highly customized, which is why don't expect the same price for every project, on a lighter note. And coming back to your point of how these particular compliances are going to work in place, I completely agree with Sanskriti, wherein which this completely happens in 3 different aspects. On the technology-wise, there should be some kind of compliances. Definitely on the price parts, which is on the commercial aspects, it will happen. And also on the, more importantly, on the standards also, some kind of standardization is required. Without that, if we try to implement or push this particular thing it's not going to sail without any kind of hurdles. It's very hard for the industry to survive till that particular point of time. Initially, even for the same ALMM also, it got pushed the same way for solar. All of a sudden, there is a kind of disruptive mechanism of shortfall of polysilicon happened in the country, which is why direct cell manufacturing is not possible, specific to solar PV. The same thing even can happen with energy storage as well. So we need to clear up these particular hurdles or breakthroughs which are already there. These roadblocks has to be cleared first. And for this particular thing, on these particular three major aspects, one has to concentrate more on this. On the technical challenges, on the commercial aspects, more importantly on the material availability, and then looking at the standardization of all these particular things. Then it's going to be a kind of cakewalk for the industry to sail with huge capacities of touching around like 360 gigawatt hour to 400 gigawatt hour by 2030 with 130 gigawatt capacity is highly acceptable and can be considered. But without that, it's a major challenge which we could foresee there.
Thanks, I totally agree with you on that. We would like to now open the floor for some questions. If there's anybody who would like to ask a question. Can you please give the mic? Sir, I request you to please introduce yourself and your company.
I'm Vineet Maheshwari from Blue Smart Mobility. My question is that these tenders are for 20 years. What is really the battery lifespan expected actually?
See, span of these particular batteries, it can be looked in two different ways. If you're trying to look the battery as a kind of standard cycle-wise, one full charge, one full discharge, probably with a depth of discharge of 90%, you easily can expect 6,000 to 8,000 cycles. But if you want to look on the name of number of years as what as a standard product is looking at, probably you easily can see from in the range of 8 to 12 years is a kind of, for this particular LFPA kind of technology, you easily can expect that. But at the end of the day, state of charge of these batteries really makes much more difference. At what particular value the life of this particular battery or duration of this particular battery is going to stand. Which is why we could see within the tenders, they ask us on years. We will be a bit confused whether to quote in number of cycles or within number of years. And even Ved also has got a kind of right concern, like if it is going to be asked in number of years, augmentation, whether this particular augmentation cost has to be considered as a kind of capex calculation itself, or we need to wait till that particular 8th year, where in which cost of these particular LFPE batteries will come down, and then we'll augment it at a later point of time. So these are certain uncertainties which cannot be ascertained, but yes, if an option is given for us, like whether you commit on number of cycles or number of years, whichever comes the first, we try to consider it. That way it is more flexible and easier for everyone to believe on technology part.
Thanks.
There was another question.
Is there a good reason for these tenders to be 20 years when the technology is changing so fast? Can't the tenders also be of shorter duration? And
So there are two types of tender. Well, we previously discussed that there are two tenders in the market. One is standalone, another one is peak power tenders. So standalone tenders, what DISCOMs are typically doing, they are defining the battery life up to 12 years. What they are asking that there should be a particular SOH of the battery at the end of 12th year. So for those projects, what they are envisaging, that the battery which they would be installing at beginning of life, that can work with a reduced capacity up to year 12. So there the problem with respect to the calendar life and the cyclic life is a bit sorted out because they have defined the number of cycles per day users also. That yearly they would be utilizing 730 cycles. Coming to the second type of projects where the general PPA terms for solar and wind is for 25 years. Now the demand is to provide a firm power, either in a specific hour of a day or to follow a demand profile shared by the tendering authority. There they don't specify that there should be a battery storage. It can be any storage. So with respect to battery, there is a limitation, which is right now, I believe, that the maximum calendar life, which even if you don't use the battery, I believe, even if you use it to the minimal capacity, the calendar life which most of the OEMs are guaranteeing, I believe, is 20 years. So there is a mismatch that with 25 years PPA, you have a technology that works only for 20 years, then it is your assumption or your risk factor that what assumption you take to replace the complete battery or whatever is your scenario. So that mismatch is there only with respect to the battery energy storage right now. But with the update in technology, believe that the next upcoming technology where we are planning for the augmentation, there the technology would be such that it can survive up to 25 years.
Hello, my name is Mukesh Kole. I represent Green Gravity, an Australia-based company. I mean, thanks for the very interesting conversation. I would like to understand in the scheme of things and various technologies being kind of developed and introduced in the market, how do you see the role of gravitational energy storage technology in this mix?
It's more importantly, if you just try to look at the technology wise, it's going to be continued with LFPE and it will remain with LFPE for the next 4 to 6 quarters for sure, and even it can be extended even up to 10 quarters also. But yes, optimization is going to happen within this technology. So that optimization is linked with increased energy density. And for that particular matter, we easily could see that the existing cell chemistry of LFPE will remain same, but the spacing between these particular cell layers are going to vary. And some kind of hybrid passivation is also going to happen. So this is what you can expect for the next 6 quarters kind of timeline. So just because of that, you can see for the same dimensions, existing 280 Ah cell can become 300, and then within span of 4 quarters, you can see 300 becoming 350. By the end of 6 quarters or 10 quarters, you can see even 500 Ah within the same dimension kind of cell. That's what you can expect.
And among these technologies, like, how do you see gravitational energy storage technology competing and supporting this whole energy transition in terms of storage?
Pumped hydro energy storage is entirely different aspect altogether. And at one particular point of time, as even Sanskriti also has rightly said, during 2019, if you just try to compare LFPE versus pumped PHS, definitely PHS is having more impactful on the numbers part. But as on date, if you just try to see, that parity is already achieved. Now it's the point is that what capacity? And going forward, since now we even could see starting from 2023 till 2028, 10.26% of CHAS is expected on a yearly basis, which is the reason why we could see that of 130 gigawatt capacity up to 360 gigawatt hours or 400 gigawatt hours is expected by 2030. So this particular tremendous increment on yearly basis is actually going to add value not only on PHS. It's actually going to add much more value on LFP. That's why you could see many number of players, or even within this particular area of Expo also, you can see a lot of LFP players are trying to portray their solutions. Just because the quantum of expected capacity is going to be added through this particular LFP. That's how it's going to work.
Thank you.
Just to add to what Sai said, I think next few years is going to be LFP consolidating the market. If we look at the energy density spectrum, right, we have NMC, LFP and LTO. We see that LFP is getting more and more energy dense and it's going to encroach on more of the NMC applications. And on the flip side, the companies are developing much faster charging and discharging LFPs as well, so it's going to keep encroaching on LTO's applications as well. So I think LFP, the scope of applications is definitely going to increase, and it's going to stay for at least the next few years.
Thank you.
Thank you so much. So now I'll just conclude and thank you so much for that very interesting and engaging discussion. So just to conclude our discussions today, like Sanskriti rightly mentioned, we shouldn't say that the market is ready to take off, it has taken off. There are very, very strong growth drivers for battery storage market, and there are some teething issues related to technology, supply chain and also cost to some extent, which needs to be addressed, because we can all agree that batteries are the need for the future and we need them for more renewable integration into the grid. With that, I would close the session. Thank you so much, panelists, again. Thank you so much, audience, for being so patient with us. Thank you.
Thank you so much, our esteemed speakers, for sparing your time and sparing your time for having this wonderful conversation in front of the audience. Thank you for the detailed perspectives and insights and sharing with us today. So, may I please take the honor to share a token of appreciation on behalf of Informa Markets India. So, I request our kind moderator, Ms. Neha Makol, Manager Consulting, Bridge to India, to please hand over a token of appreciation to Ms. Sanskriti Dubey, Senior Manager, Market Growth and Communications, Fluence India. Also, I would like to hand over the token of appreciation to Mr. Praneeth Pillariseti, Senior Product Manager, Stationary Storage Systems, Long 9 Materials. Also, we would like to hand over a token of appreciation to Mr. Charan Kuppili, Technical Director, Jinko Solar. Also, now we would like to hand over a token of appreciation to Mr. Naveen Nagpal, Assistant Vice President, Renewables, BESS, and New Initiatives, BSES. Now, we have Mr. Ved Prakash Tiwari, Assistant General Manager, O2 Power. Now I please take the honor of sharing the token of appreciation on behalf of Informa Markets India to Ms. Neha Makol, Manager, Consulting, Bridge to India. May we please have a photo opportunity with all our esteemed speakers and our kind moderator for the session.